Welcome to The Explainer. You know, in engineering, sometimes the difference between safety and total disaster comes down to a few simple words. Today, we're talking about pressure, and we're going to get into why getting the terminology right is just absolutely critical. Sounds pretty dramatic, right? But could one wrong number really lead to a catastrophic failure? Well, in high-stakes industrial environments, the answer is a resounding yes. A single misunderstood term can be that first domino to fall, leading to a disaster. So the big question is, how do engineers stop that from happening? Well, it all comes down to precision. And I'm not just talking about the calculations, I'm talking about the language itself. To build a system that's truly safe, everyone, from the person designing it to the person operating it, has to be speaking the exact same language. Today, we're going to break down the three fundamental pillars of that language: design, operating, and test pressure. All right, so let's start with the very first one, the blueprint for safety. This is design pressure. So what is it? Well, it's the theoretical maximum. It's the number engineers use right at the very beginning of a project to decide literally everything: how thick the pipes need to be, what kind of steel to use, which bolts are strong enough. It is the absolute ceiling the system is built to handle. And a bridge is actually the perfect analogy for this. Think of its design pressure as the absolute maximum weight it's built to support. We're talking a complete traffic jam filled with the heaviest trucks imaginable, all happening during a hurricane. It's the definitive worst-case scenario number. So that's the blueprint. Our second pillar is where that blueprint smacks right into reality. We're talking about operating pressure. This one's pretty much exactly what it sounds like. It's the pressure a system runs at every single day under totally normal conditions. It's not the what-if scenario. This is your Tuesday afternoon, business as usual pressure. So let's go back to our bridge. If the design pressure was that insane worst-case traffic jam, then the operating pressure is just the regular day-to-day flow of cars and trucks. It's the expected routine load that the bridge handles constantly without even breaking a sweat. Okay, so we've got the blueprint and we've got the daily reality. But how do you prove the system was built correctly before you put it into service? Well, that brings us to our third pillar: test pressure. Test pressure is all about a deliberate, controlled overpressurization of the system. Before a system ever sees active duty, engineers will fill it up, usually with water for what's called a hydrostatic test, and they pump that pressure way up, even above the design pressure. Why? To make sure every single weld, every joint, every component is absolutely flawless. And to wrap up our bridge analogy, the test pressure is kind of like the big ribbon-cutting ceremony. Before anyone from the public is allowed on, the engineers drive a whole convoy of incredibly heavy, pre-weighed trucks across it. It's a one-time event to prove, without a shadow of a doubt, that the bridge is safe and built exactly to spec. So we have these three totally distinct pressures. How do they actually work together? This is where we get to the absolute core concept of the engineering safety margin. This chart lays it all out perfectly. As you can see, the operating pressure is the lowest. Then there's a pretty big gap up to the design pressure, and the test pressure is even higher still. Now those gaps, they are not just empty space. That space is the safety margin. In fact, engineering codes and standards literally require these separations. It's all to make sure that even if a sudden surge takes the pressure above its normal operating level, there's still a massive buffer before it ever gets close to the system's design limit. And listen, this isn't just some abstract theory. It has huge real-world consequences. So let's take a look at how this all plays out in practice. Okay, so one of the most dangerous and honestly most common mix-ups out there is confusing design pressure and operating pressure. Someone might see the design pressure on a spec sheet and think, great, we can run the system at that level. But no, that's like driving your car with the engine constantly at the red line. Sure, it's designed to handle it for a short burst, but it's not meant to live there. Doing that just completely erases your safety margin. So what does good engineering practice actually look like? Well, it really boils down to two things: diligence and crystal clear communication. You have to always double-check the documentation. You've got to be super specific when you talk about pressure. Are you talking design, operating, or test? And this is critical. You never ever run a system above its maximum allowable operating pressure, or MAOP, which is set specifically to keep those safety margins intact. And all of this brings us to a final thought. These safety margins are meticulously planned out for things we expect to happen. But how do engineers prepare for the truly unexpected? Well, understanding this fundamental language of pressure, what we've just talked about, is the first most essential step in answering that question and in building systems that are not just safe, but truly resilient.